So if you're looking at the board, I posted this on Discord as well. The general agenda of what we want to do today is we're going to continue with that code walkthrough, looking at that NPR Tech News example. So we kind of ended off yesterday looking at version 2 of that, and I want to finish up just showing you something on that version 2 before we go to version 3. So version 3 we'll look at how do we check for internet connectivity, and how do we do that kind of in an instantaneous way. It's just say on demand, I want to know, is there connectivity? Version 4 we'll look at monitoring that connectivity and actually looking at events that tell us it's connected or disconnected and working with that, rather than asking when we need it. We'll keep a track of whether or not it's connected or not. And then the 5th version we'll look at using threads and looking at cancellation. How do you cancel a task in that kind of process? And that's going to get us out of like, how do we do this without an async task? How do we do this with just a thread? Cool. So that's kind of what I want to talk about. I'm actually going to move retrofit to tomorrow, given that we kind of ran long yesterday. And when I want you to get started, then from there you should have enough to do the quiz that's up on Inside Ranken for that. Once we finish those examples. What I want you then to get started on as far as lab work goes, eBay's got a REST API, and I think it'd be a good time to kind of maybe play around with that as kind of our lab exercise. I'd mentioned yesterday, you know, I kind of was looking, it's like, well, I'm using this tech news as an example, the NPR feed was like, well, so I can't really give that out as a lab because I want to give you some code samples to go with that. So like, okay, I need to pick a different API in terms of what we do for lab work. So that's going to be the story. Okay. So one of the things you'll need to do, and we can talk about this when we finish the theory portion, is you'll need to create a developer account and kind of get the process started. So you're ready to kind of dive in there and play with it. Cool. Okay. I need to turn one of the lights off. I'm going to start with version 2. So I'm going to open up version 2 of this project. All right. Trust project. I have pushed out some updates to this example code. So to make sure that you have that, you'll want to go up here in the toolbar where it says the little green down arrow and go ahead and hit update project. That will pull down my code changes into your local copy of the repository. That way you make sure you're looking at the most recent code. So looking into version 2, running this on my Nexus device.
I got two options when I tried doing that.
Yep.
One was merge and one was rebase.
Merge.
Merge?
Actually, just pick merge. Just pick merge. Rebase might be, because you're not making changes to it, might be a better choice, but go ahead and just do merge.
Perfect.
So what we had, remember yesterday, is I could hit this fetch button and it would go fetch the JSON feed and just spit it out here, right? So we're not doing any formatting or any parsing with it. We're just getting the data, the raw text, and spitting it out. Cool. Now, one of the things there's two things I want to kind of call to your attention and mention here. One thing is, notice that up here in the pull down, there's a few options related to network connectivity. Remember, with most cell phones, they can be connected either via Wi-Fi or they can connect via cellular. We can configure and turn on and off both of those things using this pull down. So we can click on the Wi-Fi. That will turn the Wi-Fi off, which means you can see it's now switched over to just cell. It's still going to work on there, but it's just going to go over the cell network instead. Android devices in general usually prefer a Wi-Fi network if it's available, but if it's not, then they typically use only if it's not, then they use the cellular network. Okay, that's not always true. Sometimes devices sometimes do favor the cell network over the Wi-Fi network if they determine that the Wi-Fi network is slow. But usually it's favoring towards the cellular network. We can also go over to the next side. You scroll over, you can see there's an option for mobile data. We can also turn off the mobile data itself. At this point, we have disconnected both the Wi-Fi and the cellular network. Cool? All right, so now both of those are connected. Let's try to fetch the data. What's happening? So notice when both of those are turned off, it did go ahead and try to do the fetch. It took some time before it actually failed. And I'm going to guess it probably took somewhere around 15 seconds because that was our connect timeout, right? So I can try this again. Now that it's actually disconnected, it will be faster now to do that. But you'll notice the error message that we're getting either way is not terribly user-friendly. You see that? It just says, error fetching news failed due to an I/O error. And the problem is, like, what's happening here, remember, is there's an I/O exception being thrown. That's what we're catching, so this is the error we're displaying. But an I/O exception can be caused by a whole host of reasons. Just because there's an I/O exception doesn't mean that there's no network. There could be network and you still get an I/O exception for a lot of reasons. Everybody hear me with that? So I can't assume just because of that there is or isn't network, right? The other side of things is notice that we're still trying to do that fetch. We're still trying to do that request, even though there isn't a network connection. So what we want to look at how to do is how do we check before we make the request in the first place. Let's go out and look to see if there's an internet connection. If there's no internet connection, well, there's no point in us trying to get the data. Does that make sense? So that's a really important thing in the Android space. It gives you better error messages to the user. B, it also actually reduces their network usage and their battery usage, because just turning on the radio for something that's going to fail is pretty expensive on the battery. Like that one request of me making that means that the radio's on for the next 1 to 5 minutes, just from that one request alone. So I only want to do that if I know that there's a good chance that it's going to go through. Cool? So that's what we want to look at here. The other thing I want to mention, I'm going to actually close this emulator and look at a different one, because this happened to me this morning. It doesn't happen often, but I have had this experience with a few students over time. So I want to make a quick mention to it. Sometimes these emulators will freak out. So I ran into an issue this morning with my emulator that it stopped actually sending network requests. It would just completely stall. If I tried to connect to the internet, it would just stop. And I think this is the one I was having trouble with. Like I'd hit fetch, that button turns gray. You can see up in the top right corner that both the two network connections are connected, right? Wi-Fi is connected, cellular is connected. But it's just hanging here. This happens sometimes with the emulators. So that's one thing to be aware of. If you're getting into this case where you're trying to make a network request and nothing's working, it might be a bug with the emulator. Everybody hear me with that? It might be a problem with your code. It might be a bug with the emulator. So one of the things you can do to determine whether or not it's a problem with your code is I went into the code down here, and after I called connection.connect, I said, let's log connected, right? And if everything's working well, it should immediately get there or immediately throw an exception. Does that make sense? Almost immediately that should happen. But if we look at the log and I filter down to just my application, it says fetching newsfeed, but it actually never got to that connected message. Okay, so this is a sign of a misbehaving emulator. Okay, this happens. This will happen. It's happened to students sometimes on tests. So you want to keep back in mind that this does occur. Now, I've showed some students about how to troubleshoot these kind of issues. What have I said if you have a problem with your emulator? What are your options?
There were 3 options, right? In
Yep.
the options menu of the AVD.
The AVD manager. So what I'm going to do is I'm going to close this out, and I'm going to go into AVD manager. And I'd actually created a second device. You can see here I've got 2 Nexus S because I wanted to be able to show that to you in class. Okay, so this one's the one that's misbehaving. I can start the emulator up here, hit launch, and that's the same thing if you like run the program. It's still going to continue being stuck. Like if you keep launching it, it's going to continue being stuck. You have some other options over here. There's 3 options that are worth mentioning. There's a cold boot option, there's a wipe data option, and there's a delete option. So cold boot, what it will do is it basically completely shuts the power down, throws away what's ever in memory, and starts the device completely as if you'd like taken the battery out and put the battery back in. That's usually the quickest way to fix issues. It doesn't always solve the issue, but it's the quickest way to just change it and get back up. Sometimes that doesn't work, so your next option is to wipe the data. Effectively wiping the data is more like factory resetting it. It's going to set it back to what it was when you created the emulator, which means you're going to have to change any settings in the operating system that you need, like auto rotate, and then resume it. Your last option, if all else fails, is you can delete the emulator and recreate it. So you can either cold boot it, wipe the data, or deleting. Those go in the ascending order in terms of how long they take to do. Like the fastest thing to do is cold boot. The second fastest thing to do is to wipe the data, and then the slowest thing is to delete it and recreate it. So where time's an issue, I usually try to do the quickest one that will fix the problem. So for this case, I'm going to actually go wipe the data because I think that most of the time my experience has been that a cold boot doesn't solve issues with with the emulators once they stop connecting to the internet. So I'm going to wipe the data on that and restart it. So if you get into that issue where all your internet connections are failing, I would recommend wiping the data and starting fresh. Cool. So when this comes back up, the emulator should function. I should be able to get out to the internet. And as you see, it's going to take some time because it's booting from power off, as well it has to kind of reset up the operating system to get back in. Now that I'm back in here, I'm going to turn auto rotate back on so that works again, and I can try to run the app on there. One of the benefits of doing a wipe data is it means all of your apps that you've installed previously are going to be gone, because sometimes that's an issue. Sometimes what is the problem is another app that you've written and run on the device, on the emulator, and not the actual app that you're trying to run. Sometimes it's another app misbehaving. So that helps eliminate that and know that, okay, the only app that's running on here is my application. Cool. So we're back up and running. Does that help for anybody? Just keep that in mind. Sometimes you do need to wipe the data. Okay, so back to our question at mind. So you've seen there's two options, right? I can turn off the Wi-Fi or I can turn off the mobile data individually. Another thing I can do is just go into airplane mode. Airplane mode will turn both of those things off. So you can test it any of those ways, and I would recommend using all three of those buttons to test, because it does behave slightly different depending on what's turning on and what's turning off, right? So sometimes you want to see what happens with it's just Wi-Fi or just cellular or in airplane mode, etc. Those are all good options to test with. Okay, so I'm going to come back into here. I'm going to go over to, now that we've kind of talked about, what's going on, right? I'm going to go over to the third version, NPR Tech News 3. Hit OK on that. You will notice for me, it did pop this up, and you'll probably see this on yours as well. So just a reminder, we're going to use the embedded JDK here. All right. So I'm going to run this on the device, and we'll look at the behavior first, and then I'll kind of tell you what's happening with the code here. So as long as the network's connected, fetch, same behavior. Okay. What's different about this version 3 is what happens when we don't have an internet connection. So I'm going to hop into airplane mode. I'm going to hit fetch. And rather than it giving me that ugly error, it just says, hey, the network is disconnected in the snack bar down at the bottom. Everybody see that? So rather than going to try and attempt to get data that's going to fail, it just tells the user, hey, this isn't going to work. You need to connect the network. Cool. So how do we do this? The code changes for this are pretty small. If you've read through the reading, the place that this is covered, there's an article on there called Read Network State. This is where this information is pulled from. But there's a little bit more here because I think their code examples were a little bit lacking. So what I've added is, let's look at the ClickListener first. In the ClickListener, previously what we were doing is just creating a task and executing it, regardless of what the state of the device was. What I've changed here is I say, well, only if it's connected do we start the task. Otherwise, I'm going to show the stack bar. So that's the part where this has changed, right? I'm just putting an if statement on the button click to say start the task or show a stack bar, depending on that state. So how do we determine if it's connected? So if you scroll down, you're going to find this function here called isConnected. Okay. So when you click the button, it calls this function. This function is going to determine true or false, yes or no. Is it connected to the internet? If it is connected to the internet, we proceed. Otherwise, we show the snack bar. What? Oh. I'm not sure what happened with my projector right there. Start it back up. So if you're looking, down, I'll start back up in a second. If you're looking at is everybody looking at the Discord stream though? Okay. So the first thing you'll see under isConnected is I'm asking for this connectivity manager. Okay. So the connectivity manager is how we actually get access to information about the network, information about both the cellular network as well as the Wi-Fi network. An interesting thing in here, the connectivity manager actually cannot tell you if you're in airplane mode or not. It can tell you whether or not the network's connected, but it can't tell you if you're in airplane mode. It can't tell you why you're connected or not connected. That may have just overheated. So I'm going to grab it. I'm going to call get system service. Get system service is how we get various components within the Android system. And you may have actually already seen this because we already used this get system service call to, remember, get the input method manager to hide this off keyboard. So you've already seen a function call to this, but now we're asking for a different system service. So system service, we're saying, hey, I want a connectivity manager. We save that to a variable, and then we're going to say, hey, if we got one, then keep going. You'll notice at the bottom of this function, I'm saying return false. So if anything fails in this process, we're going to say that it's not connected. Does that make sense? So the default basically is that it's not connected. It's only connected if all of this stuff is true and functioning. Okay. So we can get the manager. That very rarely will return null. So that one's not one we have to worry too much about. The next thing I do is from the manager, I ask for the active network. Okay. I ask for what network are you currently using? You're using the cellular network or using the Wi-Fi network. So it will return information about the appropriate one that's currently using. In the case where you're, say, in airplane mode or both of those are disconnected, that's where you're going to get a null back. You're going to get a null back from the active network if you're inactive in airplane mode. So that's one of the reasons here we do absolutely need to check for null. If we don't check for null here, the application crashes, null pointer exception, etc. So we say, hey, if there's a network, then we can do the next step. Okay? So if there is a network that we're connected to, I can ask for what we call its capabilities. What is it capable of? And the way we get that is we go back to the manager, we say get network capabilities, and we pass in the network that we got before. So notice here that it takes that network, the active network. We say, what are the capabilities of that network? That's going to return us an object or not. If it doesn't return an object, we're just going to assume that it doesn't have any capabilities, or those capabilities aren't known yet, which is a possibility. In the process of connecting, it may not have determined the capabilities yet. If it has determined the capabilities, then we can ask for specific capabilities that it has. Okay? Now, the capability we're interested in is, can that network connect to the internet? So we say network capabilities dot has capability, and we pass in this constant. We say, does it have the internet capability? So this is going to return true or false. If it does have the ability to connect to the internet, true, good, okay. At this point, we know that it's connected. If that failed, well, there's no internet connectivity. As far as we're concerned, it's disconnected. That might be a case where maybe you're on a Wi-Fi network, and that's your only connection, but that Wi-Fi network can't get out to the internet. Then you would have a network, an active network, but not the internet capability. Does that make sense? Mm-hmm. So that can happen, or if it's a different kind of network that for whatever reason just doesn't have internet access. So maybe they're on the cellular network, but they don't have a data plan, right? Those kind of issues can happen, so we want to make sure that it's something that's actually capable of that. Cool? So that's the whole process of checking for connectivity. You'll notice there's a bunch of if statements in there. Those if statements are important just to make sure that your application doesn't crash. Because a lot of these things have edge cases. One of the things with working with these networks is a lot of times you'll find that most of the time certain things work, except in some narrow boundary cases. And so you have to account for those narrow boundary cases, which is why I've got those 3 sets of if statements that count for those bound cases that don't happen all the time. Cool? Okay, any questions on that? Does that make sense in sort of just checking the connectivity? And this function you can basically drop into any application, and it'll tell you, hey, is there internet connection or not? You can modify this if you're interested in other things, but that's basically how we just go and say, is it connected right now? Cool. There are some caveats to this, namely that it means every time we want to do something, we have to go through this whole process. we have to go introspect the system and ask for the manager, the network, and the network compatibilities, and then ask if there's an internet compatibility. So it's a bit of work to do every time you want to make a connection. Not a real big deal here because we're just doing one request when the user clicks the button. But you may find that you initiate an operation and maybe that operation needs to make hundreds of network requests. Well, we don't want to do this hundreds of times. Make sense? And also a matter of oftentimes the connectivity can change over time. So this only gives us a way to know at any given time what it is. But we may want to initiate things, say, hey, we want to go initiate or fetch the feed when the network comes online, or we may want to do something else when the network goes offline. So we might immediately want to, for instance, show a snack bar and say, hey, you just got disconnected from the network, or you got connected to the network, or other sorts of things, right? You may want to react to the changes in the network state. And that ends up being a lot more efficient. Just overall in general, it's a lot more efficient to monitor oftentimes the network state rather than to just ask it at any given instant what it is. Cool? Everybody with me there? So the next example, what I want to look at is I'm going to actually take this isConnected function back out, and we're going to look at how do we monitor it, how do we get events related to the network. Now, before I leave this, I almost forgot, I want to make one mention here. There's some code here that's commented out. This is the old way that we had to check for connectivity. If you look at your book, chapter 7.2, that's what it talks about. So we used to use this network info object to check whether or not the network is connected. That API is now deprecated. So network info, get network info, etc. This whole API, if you try to use it, you'll get errors and warnings about it. So that's why this is a little bit newer than what is in your book. Cool. Again, the online article is up to date, but the textbook is not in this regard. So let's go look at example number 4. Go run that on the emulator. Okay. So what's different here is you'll notice first on the UI that there's some text here. It says disconnected and there's a little icon next to it, right? And that's currently because I'm in airplane mode. If I hop out of airplane mode, it should get reconnected, and now it says connected with a different icon. So I've got some code in here, as I said, that is monitoring the network state and changing the UI when it changes. So that's one part of that. And then I'm also using that to track a variable that determines, okay, we can continue going through and fetching it if it's there. And if we go back to airplane mode, it's going to give us that same snack bar. Just the difference is I'm using a variable that's tracking it over time rather than asking every time you click the button. Does that make sense? So I track the events with the network rather than trying to check periodically. Okay, so let's look at what the code changes are here. As I mentioned, there isn't a isConnected function anymore. So I've done away with that, and we're going to do something a little bit different. So what we're looking at is, let me go look at the ClickListener first. So in the ClickListener, notice how the if statement's slightly different, right? Rather than isConnected parentheses, it's not calling a function anymore. It's just referring to a member variable, a state variable. So there's a state variable I have now called isConnected. It's a Boolean variable. So it just says, is that variable true or false? And we react to that rather than calling a function. Okay, that's the first big difference there. The next thing you'll see in the onCreate is you'll see that there's a little pair of lines here for network events. I say, let's get the connectivity manager, and then let's register a callback with that connectivity manager. So you notice I'm saying register default network callback. So that says register this callback. It's like kind of like an event listener, listens for events for the network, and we're saying I want to listen for changes to the default network also known as the active network. So whatever network you're currently using to connect to the internet. Cool. So I register a listener for that in onCreate. And if I flip over to onDestroy, you'll notice there's also some corresponding opposite code over there where I say, hey, if we have the connectivity manager, then unregister my callback. This part is really important. This part is really important. If you don't unregister the callback, that callback will continue going. And so your activity, even though it's not on screen anymore, will continue receiving these network events. So it's really important that whenever you register this callback, you make sure that that callback also gets unregistered in onDestroy. Everybody good with that? So those two parts are kind of what's happening here. Is we register it in onCreate, we unregister it in onDestroy. So now let's look at what that callback is. So that callback's located up here. We need to look a little bit about what the state variables are. So we kind of saw already, mentioned in that OnClickListener, that I've got a Boolean. So I've got a Boolean is connected. I've got a reference to the connectivity manager, which I'm getting in onCreate, and I'm using in onDestroy to clean up after myself, right? So I'm keeping a reference around to that connectivity manager so I don't have to ask for it every time I need it. Cool? So I don't have to call get system service repeatedly. The next thing you'll see in here, and I've collapsed it to make it easier to read, is you'll see that there is this private final connectivity manager.network callback variable. Okay, this is where I'm storing my network callback. You'll notice it's final. Final again means it can't be reassigned. So I create this network callback once, and I don't want to recreate it. The reason I don't want to recreate it is then if I change that variable, then I won't be unregistering the same callback that I registered at the beginning. Does that make sense? That's why it needs to be final. If it's not final, then you open yourself up the door to registering one callback and unregistering a different callback. Do you hear me on that? Because we want to make sure that we unregister that callback. Okay. So what's happening in that callback? So this is an anonymous class. This connectivity is an anonymous class because connectivity this network callback is an interface, right? So what we've got here, if I go to network callback, actually I take that back. It's a static class. So it's a static class that we're subclassing. We're creating an anonymous subclass of it. There's a whole bunch of methods, as you can see, in that network callback, but here we're only going to be looking at 3 because that's all we're interested in. So, what are the 3 methods I'm overriding? Okay. So the first one I'm overriding is this function called OnAvailable. So OnAvailable gets triggered when the device switches to a new default network. So when the default network switches to, say, Cellular, switches to Wi-Fi, or switches potentially from maybe one Wi-Fi network to another Wi-Fi network, you'll get this OnAvailable being called. So it'll tell you, here's the new network that I'm connected to. You might notice that the only thing I'm doing in here is logging, because it turns out I really don't want to do anything in that particular callback. Okay, I don't actually want to do anything at that point. I just want to say, write it to the log so we can see that something occurred, right? Where I'm actually doing my logic is in the next function here, on capabilities changed. In fact, you're guaranteed, if you read the docs, you're guaranteed that anytime OnAvailable is called, on capabilities will be called a little bit later. And because what I really am interested in is the capabilities, that's where I'm doing all the logic over there rather than doing it in the OnAvailable call. Cool? Basically in OnAvailable, it doesn't know the capabilities yet, so I need to postpone that process. So onCapabilities changed tells you both the network and the network capabilities. That's the information I needed. Remember, with that is connected call. So this onCapabilities change will get called in a few conditions. It'll get called anytime the network actually changes. It'll also get called anytime the actual capabilities change. So let's say you're connecting and it hasn't figured out, maybe initially it's connected and it hasn't figured out if there's internet access. You may initially get in here with one set of capabilities, and then later it may find, oh yes, there is a working network internet connection. It'll call this function again. Cool. So this may get called a few times in the process of connecting or in the process of connecting. So inside of this, I'm updating the isConnected variable, right? That's that variable that we're using to determine what happens when you click the button. So I'm asking for two things. I'm asking for internet capabilities, right? So network capabilities has capability, network, internet. Same thing we saw in the previous example, right? It's just I'm asking for it in an event handler instead of when you click the button, right? So I'm asking for internet capability. And I'm also asking for this validated capability, okay? So internet says, does it potentially have internet capabilities? The second part, that validated, says, have we checked that it has internet capabilities? Have we made a request? So actually what happens with the Android device, it'll connect to the network and say, oh, okay, let's try to go out there. Let's try to hit a website of some sort and see if that goes through. If that goes through, it becomes validated. Does that make sense? So I'm waiting essentially now until it's checked, until it's had a chance to verify that there actually is a good connection. So if both of those things are true, those both return true or false, so there's an and to combine them. Then we'll say that is connected. I'm logging that status, and then I'm doing something here, right? So does that, before I talk about what's going on with this last line, does that first part make sense, right? So we just say, hey, does it have these two capabilities at this point in time? If it has internet, it has validated, we're good, we're connected. Let me come back to this last method and talk about what's going on there. So I'm going to comment this out for a minute. Over on my third callback, on lost specifically gets called when there is no active network. Okay. If you get, say, an airplane mode, or you turn off both Wi-Fi and cellular, you'll get a call to this on lost that says there's nothing connected, there's nothing I can use. So at that point, I'm saying it's disconnected. Cool. Everybody following with that? So let's try that real quick and let's look at what's happening with the logs. So I want to show you what's happening here. I'm going to go into running the program. I'm going to pull up Logcat while we're doing that. And maybe we could see what is being logged. So we can kind of track that. So, I'm going to look for info, NPR tech news to filter down to just the interesting things. And so we'll notice right now I'm in airplane mode, right? So if you're in airplane mode when the application starts, when it hooks up the callback, notice the callback doesn't get called. Like that's the first thing to notice, if it doesn't get called. So that means it's important that the connected flag starts out as false. It has to start out as false because initially that has to be your assumption, right? It's only connected once you get notified that it's connected. Cool? If, on the other hand, I start with it not in airplane mode, so let's get back to connected, and I'm going to try and just run the application again, we'll see that a different sequence of events happens, right? So if it starts out that the app is connected, is disconnected, you won't get in a callback at all, but if it starts out connected, you'll get these two lines here. Connected to 107, network 107 has internet connection true. That 107 number will likely be different on your own machine if you try it. That increments, I believe it starts at 100 and increments over time. So here, we can see what's happening here. So we see that it called OnAvailable first, and then it called OnCapabilities changed, right? Both of these with the same network, but the second one we were able to check the capabilities and determine that it did have internet connectivity. If I go to switch it over to airplane mode, watch the logs, you see how it says disconnected from 107, right? So we can see that it's calling this method here. So the logging is very helpful to see what is going on behind the scenes, right? Oftentimes there may be things that you can't see any other way than logging, especially related to this. I'm going to go back to turning airplane mode back off. We'll see that we got a few different messages when I turned airplane mode off. It first said that it was connected to this 108 network, and then it said, hey, it doesn't have network connectivity, until at this point it does have that internet connectivity. You'll notice then it also switched over to this. So basically what's happening here, this first one, 108, more than likely is the cellular turning on. And then the second one, 109, would be the Wi-Fi turning on. Right? So you can see there's a few things that happen, quite a few events that often occur when you're going from airplane mode to off and on. Cool. Does that make sense in terms of callback? The big difference here, right, is notice that I'm putting this into a variable, and I'm actually declaring this outside of onCreate. Okay. I have told some people that usually you don't want to create things out of onCreate. This is one exception to the rule where it really has to be, because I need to keep this around and because I need to have it both in onCreate and in OnDestroy. So there's really no way around declaring it here. The good news, though, is this is actually not running any code. Notice that this is declaring or creating a network callback, but the network callback isn't being executed at this point. The network callback is only executed once there is a network event. So that'll be quite a bit later after onCreate. Does that make sense? So while it looks like I might be running code before onCreate, I'm not actually writing code before onCreate. Cool. Okay. So let's talk about what's happening with the events and how I'm updating the UI. So the obvious thing would be here is, okay, once it's connected, let's just update the text. So maybe here, when I get into having that event, let's say show connected. And here I'm going to say show connected, and just call this function directly. So let's look at what show connected is. So show connected says if it's connected, then we're going to set the text to connected, and we're going to change the icon to on. If it's disconnected, we're going to set it to disconnected and turn it off. Cool? Makes sense? Pretty simple. We're just changing the text and the icon based on the state. Now, watch what happens when I try to run the program. When I try to run the program right now, in this state, we're going to see some behavior. If I can get it to start. Okay. So it started up successfully, just fine, right? And you can see that it got connected, okay? So this initial run through, it's all good. Watch what happens when I switch into airplane mode. Boop. Where'd my app go? Well, my app crashed. Okay, so let's try and figure out why my app crashed. If I go to the error level and look at the stack trace, there is a stack trace here. Okay, so what it says is called from wrong thread exception. Only the original thread created, a view hierarchy can touch its views. So what's happening is what we talked about yesterday, in that you can't modify or access the views or the UI in a background thread. Only the main thread, only the UI thread can access the UI. Okay, so that's kind of interesting. For this network callback, did I create any additional threads or async tasks? No. So why is it complaining about not being on the main thread? If I look at where the error is coming from, if I look at logcat and I go down here, it's going to point me to that it happens, it's caused by trying to change the text to disconnected, right? So it's part of this. It's basically I can't call show connected on the wrong thread. Notice where show connected is being called from this onLost callback. What does that tell us about the onLost callback?
That runs in the background thread.
Yes, often. In fact, you're actually seeing a weird behavior that initially when the app starts up, these callbacks are actually called on the main thread, but then later they're called on the background thread. So the thing to understand is that the connectivity manager actually sets up a set of background threads. We call it a thread pool, and it uses those background threads to invoke these callbacks. Does that make sense? So once the application starts up, all of these different events, OnAvailable, OnCapabilities changed, OnLost, those are all called from the background. They're not called from the foreground. Cool?
So can you pretty much expect all of the override functions, the ones that were inside whatever we're extending?
Yes.
So assume all of those are background thread?
Yes. I believe as far as this network callback is concerned, all of these are called on the background thread, and you should assume that they're just called on the background thread.
So how does the scope work then? You said earlier that in background threads you can't do anything as far as the activity.
Yep.
Like you have to send that data back so that it can be utilized from the main thread.
Yep.
So how are you online?
So the way I'm going to do this, notice both of here, right? In OnCapabilities change and OnLost, I'm changing the isConnected variable.
Mm-hmm.
Everybody see that?
Mm-hmm.
IsConnected variable, I'm actually going to be reading both from, I'm going to be accessing isConnected from both threads. So I'm writing isConnected from the background thread, from the callback, but I will be reading isConnected from the foreground thread, from the main thread.
Okay.
So they're sharing that variable. That's how I'm sharing the state between both sides, is through that isConnected variable. Okay. That does mean I have to be careful about something called race conditions, where they're both reading and writing potentially at the same time. But because it's just a Boolean, I'm safe. They're either both going to see false or they're both going to see true. That's a little bit more of an issue if you have an object there. But the good news is I don't have an object there. I don't need one right now. So what I'm going to do, rather than calling show connected directly, I'm going to use this function run on UI thread. That's my workaround. Is they say run on UI thread. So what this says, it's a method on the activity. It says here's a bit of work, here's a job that I want you to run when you have an opening on the main thread. So it doesn't run immediately. That's an important thing to understand. When I call run on UI thread, it's not at all guaranteed to run immediately. It's going to run at the next available open slot. Cool? So the next time it has time to work with the view, it's going to run the code that we provided. So the code that I'm providing is a short little lambda that just says, hey, I take in no parameters, call show connected. Specifically, run on UI thread takes a runnable object, and a runnable object has that signature. Takes no parameters, returns no result. So no parameters, returns void. So that's all I need to provide it. Is a short
the method signature, right?
Yep, basically that same thing. It needs to have that signature, not taking anything in, and returning void. So I just say, hey, call show connected on the UI thread. Rather than calling it on the background thread where you're at, queue it up to run later. Cool? So that's how I'm communicating from the background thread that this runs on to the foreground thread. I just say run on UI thread. I could have used an async task here, but an async task would be way excessive for a short little thing like this. Cool. And it turns out this is actually overall better to rather do it in this one line. So that's one trick you can use. Anytime you have stuff that's running on the background thread, you can use run on UI thread to transfer that work over to the main thread. One thing you might want to pay attention to is notice that the function I have here that's running on the main thread is doing very little work. It's not doing a lot of work. So most of the work is happening on the background thread. Only a little bit of the work is happening on the main thread. That's to make sure that I don't block the main thread. Cool? All good? Common mistake is to put too much work on the main thread. Now, I might want to look at two things here related to the connected, which I didn't talk about. You might notice that there's a change to the layout, partly to accommodate this. So previously I didn't have a place to the previous versions, I didn't have a place to actually show this. So in the layout, go to blueprint, there's two additional pieces here. I've anchored the button to the left instead of the center, and then I've got a pair of text views and image view widgets. Okay, so the text view is where I'm showing that status, and the image view is where I'm showing that icon. Okay, so those are the two additional components that I've added. Okay, text view is pretty simple. We've talked about how to work with text views before. You might want to look at how I've done the constraints, because the constraints are kind of an interesting place here. You'll notice that there's a baseline constraint on there that's keeping things in line and such. But let's talk about the icon real quick. So anytime you want to show an image in Android, the normal component to use there is an image view. So that's what we have here. In terms of configuring what icons shown out of the box, that comes from this source compat attribute. So source compat says, here is the starting or the default icon that appears. So you can see initially it's showing disconnected and off, because remember, my assumption is until I'm told that it's connected, I have to assume that it's disconnected. That's a non-optional thing. That's because of how the network callback works. Network callback, if you don't receive anything, you're disconnected. Cool? Everybody good with that? Okay. So that has to be in the disconnected state. Let's look at how I got those icons. So over under Drawable? Yeah. Over under Drawable, you'll see that there is my launcher icon, but there's also two additional icons. So I've got IC Wi-Fi off and IC Wi-Fi on. Those are the two icon files that I'm using. Cool? Now, how did I get those? The way I got those is I right-click on Drawable. I go to New. There's two options here. You can do it either way. You can create an image asset or you can create a vector asset. So specifically what I did is I created a vector asset. Okay. In here, what I picked is I picked from the clip art. So if you look under Wi-Fi, when it opens up, you'll see that there's a bunch of Wi-Fi icons available. And what I picked here was the on is that 4-bar on, and the off is this one here. So I just picked those icons. Okay. So when I pick one of these icons, I hit OK. It's by default going to fill in that name. It's going to fill in the default name of that clip art icon. Oftentimes that name like this you can see is a very long name. So I oftentimes shorten it to something shorter that represents really what I'm going to use it for. So I might type in here IC Wi-Fi. The IC part at the beginning specifies that this is an icon. So it's convention to start all of your icons with IC underscore. But that's really it. Is I just picked an icon, I gave it a name, I hit next, and I saved it. That's it. So that's how you can add additional icons to your application. Cool? Questions? Does that make sense? Okay. So this comes up all the time. That's how you get those icons. All right. So we've seen how to kind of monitor the state, right? So the difference here again is we're still using Connectivity Manager, but we're using a network callback to monitor it. I'm also providing a way for the user to see whether or not the network is connected. The last thing that we'll notice in there too is I showed you a new way to do the communication between the background thread and the foreground, between background threads and foreground threads, or the main thread. Okay. So the next thing I want to look at is, remember that we kind of saw the async task is deprecated, right? The recommendation from Android's perspective is that you shouldn't use Asynctask anymore, right? They're recommending that you use other tools. So what I want to show you is how to do this without an async task. So remember, right now we have this Patchtask class right now that is a subclass of async task. Cool. What I'm going to do is I'm going to make my own version of this effectively without using async task. So let's jump over to version 5. Trust the project, embedded JDK. And in here, so as far as the app behaves, this is going to behave the exact same way that the previous version did. The difference is in the implementation. Okay. Other than that, it's the same thing. So let's look at what's different in the code. So what's changed is entirely in the main activity class. So as I've done before, where I'm going to start, the first line I want to look at, what happened here? I don't know why my network callback moved up. This should be up here. I don't know why that stuff got moved around. So network callback still there. In terms of the OnClickListener, I'm doing something a little bit different. So rather than what I had put here previously is I'd said check if it's connected and then create the task and execute, right? So instead I've got a function called startFetch and I'm calling that from here, right? So I call startFetch when you click the button. Cool. Because I needed to move the code around a little bit. So let's go to what happens when you click the button. So when you click the button, I do a few things. Now, because I'm going to be using something called the subclass of thread instead of a subclass of async task. Async task, remember, gave me those on pre-execute and the on post-execute functions. I basically don't have those. I have to kind of implement that logic myself. So previously I had in on pre-execute, I was disabling the button. I've had to move that code that was an on pre-execute to here. So when we call startFetch, we're going to check if it's connected. If it's connected, we proceed with this code. Otherwise, we show the stack bar. If it's connected, we're going to disable the button. You'll notice that I'm checking if there previously was a task that we started. If there's a task we'd started already, I'm going to cancel that task. And I'm going to create and start a new task. Okay. Now, one thing I recognize here, I'm calling start instead of calling execute. How you start an async task is you call execute on it. How you start a thread is you call start on it. So it's a slightly different function, execute versus start, but they actually do the same thing. Cool? So that's what happens when I initiate this. So let's look at what the fetch task looks like now. So fetch task now, rather than being a subclass of async task, I've made it a subclass of thread. So thread is a much older class in Java. Has been with Java almost from the beginning, and is the basic way of like, hey, I want to make my own thread. I'll make a subclass of thread and tell it what to do when that thread runs. Okay. As far as subclassing thread, it's super easy. The only method you have to override is the run method. The run method is all the code that will happen on that thread you created. So run is kind of like do in background. Same idea, right? So the code that's running in the background is now in run instead of do in background. Okay. So we tell it to run. You'll also notice that I have a flag here to determine if the task is canceled. So I say, hey, make a private boolean. By default, it's not canceled. And there's a method here called cancel that you can use to cancel the task. Inside of there, I mark canceled as true, and then I interrupt the thread. Interrupting the thread, what that does is it wakes it up from sleep. If it was sleep waiting for something to happen, that's going to wake it up so it can immediately stop. Otherwise, it would have to wait until the sleeping's done before it can come back up and determine that it's been canceled. Because I want it to immediately, find out I'm canceled and stop. Cool? So that's how I'm implementing this. That's something you have to, if you're using a thread, you have to implement yourself because there's no sort of cancellation method. There's no cancellation mechanism built into threads. You have to build that part yourself. There's some stuff in an async task that deals with cancellation. There's still stuff you have to do yourself to fully make it work. But this is something where you have to understand the whole system. Okay, so let's look at what we're doing in the run method. The run method, very similar to what we've done before. I've got up at the top, I'm declaring the connection, and I'm saying, hey, we've got a result that's going to come out of this operation. Cool? I then got my try, so we need to create the URL. We need to open that connection. We're going to do all of our input stream stuff. One of the things you'll notice that is different here is as I'm reading line by line, I'm also checking whether or not it's canceled. Okay. The reason I'm doing is if this task gets canceled, I don't need to keep downloading the response. I can stop at that point and say, okay, I don't care about what's left. We're just going to stop at this point. Does that make sense? Otherwise, if I didn't check that there, we'd keep reading and not stop. Your question?
Before we had no way to stop midway, right?
Before, what I missed is I should have said not is canceled here, and I forgot to put that in the previous code example. But that should have been in the async task as well. We should have been checking. Okay. But if you don't do that, then it's not going to stop it. You're going to tell it to cancel, but it'll keep going. Okay. So that's important. If you have loops that are happening on background threads, any way, shape, or form, make sure that in those loops you're checking for cancellation, so you have an off-ramp to abort the process for a loop. So if it's canceled, we're going to exit out of there prematurely. Then down here, you'll notice that I'm setting the result to refetch result sv2 string null. So I'm creating the result and I'm saving it to that result variable. I'm not returning it because this run method is void. it can't return anything. So I have to save it to a variable and then later do something with it. Doing background, you did have the option of returning something. It would automatically go to that onPostExecute method. That's not built in with threads, so we have to kind of make that communication happen ourselves. Cool? Okay, so I saved the result. We'll come back to the error handling. And then at the end here, what I do is I use that runOnUIThread method that we had to communicate back to the main thread. So when we get to the end of this process, I say runOnUIThread. We're going to run the onFetchResult function. I kind of skipped over that. We can look at that in a minute. And I'm sending this result back to the main thread. Cool? That's what we're doing. So on the end, I'm sending it to this function. This is the function that's going to update the UI. So it's kind of similar to our onPostExecute. Cool? You might notice here I have something interesting going on. Notice I have this final result variable. The gotcha is, in order for this lambda to work, this lambda needs to have a variable that is marked final. Because the problem with I mark it in the try, I change results, and I also change it in the caches. It needs to be final down here. So what I'm doing is I'm making a copy of the reference to this variable final result, and then using that here instead of using result directly. Let me just show you what happens if I don't do that. So if I don't do that trick, here you'll see a red underline on it. Can I get the error there? It says variable used in lambda expression should be final or effectively final. So any variables that you're using within a lambda like this, not just runOnUIThread, have to effectively be final, meaning that they can't be reassigned, right? It has to be known at that point what the variable is. And it turns out at this point the compiler doesn't know that. Cool. So that's what I'm doing here. Okay. Let's look at the exception cases real quick. The exception cases, if there's an error, then I'm just assigning a result, a new fetch result, which contains both the error message and the exception that occurred. That's all I'm doing. So we'll get a result with an exception if anything failed, or we'll get this successful result. You'll also notice if the task is canceled, the listener, whoever started this task, doesn't care how it ended. So I'm not doing anything with the result if the task is canceled. Okay. That part's really important because remember, one of the things that's canceling this task is up in the onDestroy. When the activity gets destroyed, I'm canceling the task. So if at that point I would continue to try to run something on the UI thread, this would throw an exception, this would cause a problem because the activity has already been destroyed. Does that make sense? If I didn't check for cancellation, I would be running something on an activity that's already gone. So that prevents that behavior.
And the destroy occurs when you close the app? Or just when you go back to the home screen?
It occurs in a lot of different scenarios. So when can onDestroy occur? This is something we haven't really talked about yet. OnDestroy can happen when the user closes the application. It doesn't happen when the user leaves the application typically, but it does happen when the user closes the app. So what do I mean by that? If I go to run the program, okay, remember I can hit square, go back to or go circle, go to the home screen, okay. The activity has not been destroyed. It's still running. The application is still running, so the activity has not been destroyed. Because I can come back here and resume and come back to the activity. It's just been paused, right? So it's just been put on hold. It hasn't actually been destroyed. Okay? On the contrary, if I go here, swipe it out, now the activity is destroyed because I've actually closed the application. Cool? So it doesn't happen when I just go back to the home screen, but it does happen when I close or dismiss the application. Another way that you can get to it being destroyed, and a good way to do this is to just add a log statement in on destroy to see what some of these cases are. Another case where this does happen, if I hit back from here, I'm going back to the home screen. That has killed the application. So if I hit back there, that oftentimes is not guaranteed. As you can kind of see, it's maybe running there. I think actually I can put a, let me put a log in there. Log.i. And maybe what I'm thinking about is when we get to multiple activities, when you go back to previous activity, I know for sure that is a case where it does get destroyed. So let me go to logcat. Check that real quick. Go here. There you can see it. So in the log, when I hit back, you can see how it called on destroy. And if I come back into and resume the application, you'll see it says on create. So if I hit back, it destroys it, and then come forward, it has to create it new from scratch. Cool? Okay. So it can happen either dismiss it, or if you back out of it. The other thing that happens is actually if you turn the screen sideways, change the orientation, this will destroy the activity and create a new one. Now it looks like I might not have auto rotation on.
I heard that about that in the documentation.
Yeah. So if you change the rotation, there you see it on destroy and on create there. So rotating the device can, leaving the application can, closing the application can destroy it. The other thing that can happen is if it's running in the background, if the activity's not actively on screen, so I go out and I leave and I start running other application. If the system is low on resources, it will destroy all the activities, all the applications that are not actively visible to the user. If it's low on resources, it will destroy everything that's not on screen. So a lot of things can cause your activity to be destroyed. So it's important to make sure that anytime that destruction happens, that you clean up after yourself. So that means, you notice what we're cleaning up already in OnDestroy. I'm cleaning up that connectivity manager because that's a system resource that we need to not hold on to. And I'm also closing or canceling that task. If the task is running, we cancel it to make sure that it's not still going and trying to fetch resources. Cool? Does that make sense? So there's a lot of things that can happen there. But the easiest way, as you can see, maybe the easiest way to do it is to just rotate the screen. Oftentimes that's the easiest way to just destroy your activity and see what happens. But because something so simple can make it happen, you have to really account for it. Cool? Okay, last thing. So we saw what happens. This is what happens when I kick off the task. We saw that happens first. Then I go do this run method. When I'm done, assuming the task hasn't been canceled, I call onFetchResult. Okay. So this is where I actually do the UI work of updating the UI. So once we're finished with the process, back on the main thread, I'll call this pass the result. We'll show the new updated update test. And if there's an error, we'll show that as well. Cool. So in a lot of ways, this should look very similar to what we did with an async task. The catch is I'm not using an async task, right? So that deprecated class is out of the mix. But it follows a lot of those same principles. The difference is I had to rebuild or reconstruct some of that functionality that I kind of got for free, right? So out of the box, Asynctask gave you those on pre-execute and on post-execute. This is basically my on pre-execute and my on post. And if I wanted to do anything with progress, I would need to implement that again myself. I'm also having to use this run on UI thread, as well as implementing the cancellation process myself to make all that happen. Okay, so that's part of why I still wanted to show you the async task, to show part of the things that we need to kind of recreate to get back to the functionalities that we need. Cool? Questions? That makes sense? Okay, so that's the theory bits that I wanted to cover today. I'm going to talk about retrofit tomorrow. Okay, we're going to talk about retrofit in JSON tomorrow. And that's going to replace a lot of this work, right? So this work that's in the try-catch, I'm going to show you an easier way to do that part, but the rest of the app will stay the same. So one of the things I want you to do is you should have enough information to go to inside Ranken and complete the homework now. Obviously review the reading material if you haven't yet. But you should be able to complete that homework quiz related to what we've talked about today and yesterday. Once you're done with that, and I think I'll give people a few minutes to do that, I want to talk a little bit about the eBay REST API so we can get you started with some hands-on work. Cool? So take a few minutes to complete that quiz, and let's say maybe back in 30 minutes or so, we'll talk about maybe the REST API. So call it 1:30. We'll come back and we'll talk about getting started with your application.